Hello and welcome to this video where we'll finally have come into data processing and coming into Pandas. And Pandas is a library that is super useful for you to learn and in your data engineering career and in your data science career. Pandas is a tool that you need to master. In this video, we will go into Pandas series and into Pandas dataframe. And later on in future videos, we will learn how to use them and manipulate the different data frames. So moving on to the Visual Studio Code here. So I'm in Visual Studio Code and I have a virtual environment with UVs. I have activated it as well. You can see it with the parentheses here. So let's install something. So we need to do UV pip install pandas. So you see that it's finished, and that is the only thing we need. And I've also installed IPyKernel. Otherwise, I don't have anything more. So let's create a new markdown here and call this Pandas series and data frame. I'll change this to Python VNV and change this to Python here. Okay, so starting with Pandas series. So what is a Pandas series? It's a 1D array, so one-dimensional array with flexible indices. And the series, it can be seen as a typed dictionary, basically. So the typing makes it more efficient than in dictionary for certain computations. So let's create a series. So we start with importing pandas as PD. So this is the normal convention. You import it as PD. And let's create something. So we have data equals dict. So this is a dictionary. And I will have different types of attribute. I will have different types of key and values for this one. For example, we could call inköp equals to 25. So basically what these are just. So this is basically just a key in Swedish. Actually, I could change it to English. So I'll just call it business equals 25. And we call it programming. Let's see, we can call it AI equals to 30. And basically, okay, so this data is corresponding to a number of students. I'll call students data. So we have number of students in each enrolled in different programs. So we have 25 in business, we have AI, we have 30, we have JavaScript and JS is 30, and we have Java is 27. Okay, so basically now we have students data. You can see that this is basically just a dictionary. So first time it runs a little bit slower, but you can see here, key values. We have key business, we have AI, we have JS 30 and Java 27, okay? And let's create the programs from this. So series program, let's create a series from this. So pandas.series data equals to data. So series is basically, that's the most simple data structure the most simple object in Pandas. So let's create this. So we have series programs. It looks like this. Let's see, data, actually not, the attribute is not called data. Students data is called actually, students data like this, okay? So you can see that it's represented in this way. So this is the Pandas series done the wrapper. It represents it in this way. So you can see there's business, there's AI, JS, Java, and we have the data type, D type is int64 here because all of them are ints. Okay, let's do a print of series program to see what happens. And the print, the done the string, it has the same representation as the done the wrapper. Okay, that is interesting. And let's continue now. Series program. If I want to do .iloc, I can find the indices, right? So I can do 0 to find the business, the value for the business, right? So I can use iloc for index location to find that. So I can do series program.iloc of -1 and I get Java, right? Or the value from Java. And you can see it's the data type is npint64, right? Okay, and moving on, we could do series program.keys, and you can see here are the keys, and you can see index. This is an object in Pandas called index. So it's the indices. So we have the index that are the keys, right? So this is important, and this we will be using when we're building up data frames. So data frames are basically a collection of series, but we'll come into that later on. Let's do it under get item. So we get, let's see, for example, AI, and we get the value from it, right? So this is an npint64 of 30. This is the wrapper of series programs AI. And to show that, we can print it, paste it in, and you can see that when we're printing it, the string gives us this value of 30. And actually, you could do calculations with it. So you do series program AI plus 50, and you can get npint 80 here, right? So 30 plus 50 is 80. Okay, so great. Let's continue creating another series. Let's create another series here. And let's see, another series. So before we created series using a dictionary. Now we create another series using a list instead. So in order for us to get a list, we could do import random as rnd. So we could generate a list, and I will do rnd.seed 42, and this means that it's the same random seed, which means that we'll get reproducible from this random. So if you run it several times, you'll get the same value. Okay, so let's do that. So dice series equals to a list comprehension now, rnd.rand int 1,6 for underscore in range 5, for example. And I use underscore as a convention whenever I don't need to use this iteration variable, right? So I don't need to use it. So by convention, I use underscore. So let's see dice series here. You can see this is just a list of a few numbers. If I rerun this one, you can see it's the same. Actually, I want to zoom in a little bit like this, so it's easier for you to follow. I would have done that in the beginning, but I forgot. Okay, so now we have a dice series. So let's see if we can do something with it. So we can do pd.series of this dice series. Or actually, it's not a dice series yet, sorry. It should be called dice list. Dice list. Like this. And dice list. And now it becomes a series. So this is a dice series. And you can see it has the indices are by default starting to count from 0. So 0, 1, 2, 3, 4. And the values are the same as the ones from the list, right? So this is our series of int64. Okay, let's create let's do some methods with this. So dice series dot. What can we do? We could do dot min to get the smallest value. We could do dice series dot max to get the largest value. You can do dice series dot mean to get average value, 3.4. So these are some methods that you can use in order to do some summary statistics of this series. And so basically you can do a lot of calculations with it, and it's based in the background. So you can see there's NumPy data types here. So things that work with NumPy also works with dataframe, or some of the things that work in NumPy work in data frames as well. Data frames and series. Okay, so talking about data frame, let's move on to data frame. Data frame. I can type it like this. So you can see it as analog of 2D NumPy array with flexible row indices and column names. And it's built upon several theories. So we'll see how that works. So let's do like this. So pd.dataframe, we can do the series program that we had before. Let's just print out the series program to see what we had. Series program is this. So based on this series, we could create a data frame from it. Actually, you can create data frames from several things. Okay, so this is basically a data frame. And we need to name the column something, otherwise it's just 0 here as default. So columns equal to, then it needs a list or a tuple. So I will give it a tuple, num students. Oh, num students, yeah, or number student. You can choose. Let's see, columns equal, actually you need a comma here in order for it to become a tuple. Yes. So now we have a data frame. So I'll call it df programs. Df usually is used for abbreviation for data frame. Data frame programs. You can see here are the keys, and here are the indices, and here are the values corresponding to this column name, right? So let's do like this. We can create 2 series objects using dictionary. So we have students equal to pd.series dict of AI equals 25, net equals 30, app equals 30, and Java equals to 27. And we could create another series, language equals pd.series dict AI equals Python, for example, net equals C#, for example, app equals Kotlin, Java, let's see, Java equals to Java. Okay, so if we just print this out, students, what do I have? Let's see, it has a misspelling here, right? Missing, another parenthesis. Okay, so students look like this, and language looks like this. Basically, we have 2 series with the same index, right? The indices are the same. However, they have different values, right? Okay, so let's create a data frame from this 2 series. So we can do pd.dataframe. So we need to have a dictionary here, and we do students. This is the column value, colon, students. So it gives the value. It gives the values from the student series, comma, language, colon, language. And you can see this is the data frame that we created. So they have the same indexes as before, and they have 2 columns, students and language. So df programs equals to this one, df programs. So now we can also create this directly. So I'm just showing different way for us to create data frames. So we could use NumPy, for example, import NumPy as NP. And we can create the data frame like this, pd.dataframe students, and it could have np.array. We need to put in 25, 30, 30, 27, for example. So then this will give us a data frame like this. However, we can continue with this. So this is a dictionary, right? You can see that curly braces, dictionary. And we can create the language here. We could have a list here. Python, C#, Kotlin, Java. And you can see here the language, right? We could actually write a list directly here or a tuple. This could be a tuple as well. However, I just want to show that NumPy array is also possible. We could have index, right? Index equals to AI, .NET, app, and Java. Let's see, index, I need to have this needs to be outside of the dictionary, like this. So it's an argument to this data frame class, right? So this data frame class has this parameter index, which now we're sending in this list as an argument. So if I run this one, you can see that we have the keys, right? Similar. Okay, so let's continue now. Let's do df programs.index. And you can see this is the index, the keys. And let's continue to data selection. So this is very important part. So when you're working with arrays, or lists, you need to use index to select items, right? And then you need to know where the index is, or you need to search it, right? And in dictionary, you have keys, key and value pairs. So you can use the keys to search for it. So in series, you could also use keys to get the value. So in data frames, you can use keys to do this. So df programs, you have already seen iloc, right? So iloc, you can get the index. So it works with data frames as well. But we can use keys. This is very powerful. So with get item, we can do students. And we can see here, or the bracket operator, students. And you get the column corresponding to students. Or basically, this is a series, right? So you can see that it looks exactly like the series which we had before. So a data frame, you can see it as it's built on several series, or one or more series becomes a data frame. We could do, if we want to select both of them, we can select multiple columns using df programs. And we have list in a list, language, students. Actually, it's language with capital L, I think. Students, like this. So we get language students, right? We could also use the dot syntax, language, and we get this series. However, don't use dot index too much, because what if you have, for example, a space in your name, in the column name, then you cannot use the dot index. And then you have to use the bracket index, bracket notation. Okay, so for example, I want to get C# value now. How can I do that? I could do df programs of language, right? Language, and I get this series. And using a series, I could use the key to get the value I want. So net, for example. And I will get C#. So cool. So now you know how to select data using in a data frame. So moving on to something called indexers. So indexers, it gives a slicing interface for the indices. So you have lock and ilock. And that works with series and with data frame objects. So with lock, you're slicing and indexing, slicing and indexing, and it's referencing explicit index, while ilock is slicing and indexing, referencing Python style index. Okay, what does that mean? It just sounds like gibberish when I'm talking like this. So let's do df programs. And we do .lock Java. Okay, what does this mean? We locate this value, this index Java. So we get the column students, 27, and the language, which is Java, right? And if we did AI, then we will get another students and language Python. And I could use df programs.lock, and I could find Java, app, and I can get 2 indices. Okay, so then the question is, why doesn't it work without the lock? What happens if I don't do the lock? I copy this one, and I just do this, and there's a key error. You can actually do try except here. Try except key error as print error. None of index Java app are in the columns, right? So when you're doing like this with the bracket notation, you will look for the column. So in order to look for the indices, you use LOC. That's why it's called indexers, right? So we go into the index. You could actually do like this also, VF programs. You could do .lock AI to app, and you're slicing, right, from AI to app. That is quite cool. This is not possible using dictionary, but in Pandas it works. In data frames it works because it's based on NumPy. So now we could also do like this: df programs.ilock, and ilock gets the index, right? So 1 gives us .net or net. So we could slice it to 3, for example. So we get net and app. Cool. So now we have used the indexers, lock and ilock. I usually rather use lock than ilock. Sometimes you might need to use ilock, but use LOC and use get normal bracket notation in order to find what you want, because you don't want to hard code the specific index because your data frame may change. So one more thing we want to learn is using masking. And we want to find things based on a certain condition, right? So we could do like this: df programs of students. I want to find where we have students larger than 25. And we can see if I do, this is a series that is returned, and it's a Boolean series. So this larger than operator it works on each element. So element-wise, so you see AI was false and the other ones are true, right? So based on this condition, we can use df programs and we use bracket notation and we send in this condition. And then it will retrieve all the rows where this condition is true. So in this way, we don't get AI, right? So this is really useful. So use this or another syntax that I will show, df programs.query. You can do query students larger than 25 and you'll get the same results. So use either this one or this one to filter out your rows. Don't use iloc in general to filter it out, unless you have a specific reason for that. Because here you have based on a condition and your data frame can be in, the rows can be in different ways than you might expect, and you might get error if you use iloc and hard code everything. Instead, filter based on conditions. That is a very good thing to do. Okay, so with this, I would like to thank you for watching this video, and you have learned about the basics in Pandas, data frame, and series. So these two objects in Pandas that are the foundation for everything in Pandas, and you can already see that we're already processing data. In the next lecture, we'll actually read in some real data from a CSV file, which we'll use and process it further. So thank you for watching this video and see you in the next one. Bye.